Topic 2, Section 3, Day 2. So we did a review of factoring, and now we're going to be writing quadratic functions in factored form. So in factored form, it's going to look like f of x equals our a, so our dilation here, and then x minus our first x-intercept times our second, x minus our second. So when it says the graph shows the function defined by y equals x squared plus 2x minus 8, how do the zeros of the function relate to the factors of the expression? So we want to go ahead and factor this, so we're going to look for what multiplies to negative 8 and adds to 2. So we have 1 and negative 8, or negative 1 and 8, 2 and negative 4, negative 2 and positive 4. So what would equal a positive 2? It would be these ones here. So we have x and x, and then we had minus 2 and plus 4. Okay, so this right here is that right there, and this is this one here. So how do these relate to this graph? So here's negative 4, that's a positive, 2, that's a negative. So how do these relate? The function is opposite of the x-intercepts. So again, these were negative and positive, and then these are the same numbers but opposite signs. So positive 4, negative 4 here. Positive 2, negative 2 here. And we'll kind of talk about why a little bit later, but for now, we can just notice that they're opposite. So go ahead and try doing this one here. Okay, so we found the multiples of 20 and what adds to negative 9. And to get a positive 20 in multiplication, we either need 2 positives or 2 negatives. But to get a negative 9 here, we needed 2 negatives, so negative 4 and negative 5 there. And then if we look at the graph, we could have also said, here's a positive 4 and a positive 5, so it's going to be negative 5 there and negative 4 there. So now, let's go ahead and look at actually solving by factoring. So we're going to find the x-intercepts by factoring. So we have solved the equation. So again, we're going to solve this by factoring. So the very first step is we're going to get it equal to 0. So it always has to equal 0 first. So we're going to move this 42 over. So we're going to subtract 42 on both sides. So now we are going to factor x squared plus x minus 42, which equals 0. So now we're back to what multiplies to negative 42 and adds to 1, because there is a 1 here. So let's do our multiplication. So we have negative 1 and 42, or we could have positive 1, negative 42, 2 and 21, 3 and 14, 6 and 7. And then we could also have 2, negative 21, 3, negative 14, 6, negative 7. So those are all our multiples to get negative 42. And then we're going to look for a positive 1. So that would be this one here. So now my factors would give me x, and then we just write in the minus 6, minus 7. And then this still equals 0. Now, if I am multiplying two numbers, so like this times this, and it equals 0, one or both of those have to equal 0. So now what we do is we take this and we set both of these equal to 0. So we have x minus 6 equals 0, or we have x minus 7 equals 0. And then we solve these. So we would add 6 to both sides. So this would be x equals 6. Same thing over here, add 7. So then x equals 7. So we have x equals 6 or x equals 7. And this right here is why it's opposite. So these are your x-intercepts. They're where they touch the x-axis. And it's opposite because you want where this would equal 0. And so it's opposite of what we see on a graph or in the equation of the x-intercepts. So let's do this one over here. So again, we got to get it equal to 0 first. So I want to keep this 2x squared positive, so I'm actually going to move the 9x over here and the 5. So I'm going to do plus 9x and minus 5 on both sides. And that's going to give me 2x squared plus 9x minus 5 equals 0. And then this is like the one we found the other day where you have to do your a times c and then adds to b. So we're going to need 2 times negative 5, which is negative 10. And so we need something that multiplies to negative 10 and adds to positive 9. So we have negative 1, positive 10. And we can keep going if we would like. Or we can see that this right here would add to 9. So we can just use these ones here. And so we have 2x squared, and then minus 1x, plus 10x, and then the minus 5 equals 0. And now we're going to factor by grouping. And so these two, the biggest they have in common is x. And so that would leave 2x minus 1. And then these, the most common is a 5. So that would leave 2x minus 1. And you can see that I'm running out of room, but we would have x plus 5 times 2x minus 1, and these still equal 0. And then now we need to set it up. So we have x plus 5 equals 0, 2x minus 1 equals 0. And solving these, we would add 1. So now we have 2x equals 1, divide by 2. So x equals 1/2. And then this one you would subtract 5 on both sides. And so we would get x equals negative 5 or x equals 1/2 for this one up here. So go ahead and pause the video and try the next two. Okay, so for this one, the answer's here, and for this one, the answer's here. I'm going to go ahead and go to example 4 now. So if you wanted to look at this a little bit longer, you would pause the video. Okay, example 4, we're looking at some real-world applications. So Marco hits a golf ball into the air from the 3rd level of driving range that is 48 feet high. The function is represented by this, gives the height, h in feet of the golf ball t seconds after it is hit in the air. When will the ball hit the ground? So we're looking for when it comes back to the ground, which is actually the x-intercept. So we're looking for the x-intercept. So we need to factor in order to find the x-intercepts. So we're going to start by pulling out the greatest common factor, if there is one. So does negative 16 go evenly into everything? And it does. So again, I'm just taking everything and dividing by negative 16. So I now have 0 because we're looking for the x-intercept. So y is 0. y equals 0 because we're looking for the x-intercept. And we're taking out a negative 16 out of everything. And so what are we left with? We're left with a positive t squared. 32 divided by negative 16 would be negative 2. Positive 48 divided by negative 16 would be negative 3. And now we have it in this form, and we are going to look for what multiplies to negative 3 and adds to negative 2. So we have 0 equals negative 16, and then we are looking for what multiplies to negative 3 and adds to negative 2. So we would have negative 3 and a positive 1. Now we're going to set all this up to 0, so 0 equals negative 16. That's not true, so there's no answer there. We have t minus 3 equals 0, and we have t plus 1 equals 0. So this would give us t equals positive 3, and this would give us t equals negative 1. Well, the ball will not hit the ground in negative seconds, so our actual answer is this t equals 3. So the ball hits the ground at 3 seconds. There it is in writing, the ball hits the ground after 3 seconds. Go ahead and try the next one. Okay, and for that one, the ball would reach after 4 seconds because, again, we do not want the negative time. So one more example and try a problem. And so now we're given the x-intercepts and a point that it passes through, and we have to write the equation. So we're going to start by plugging in the x-intercepts. And remember, when we put them into the equation, it's going to be opposite because it starts as x minus and x minus, and then we plug in those there. So we have negative 2 and we have a negative 1. Then those become positive, so we have y equals a times x plus 2 and x plus 1. And then we're going to take this point right here that it gives us, we're going to plug it in for x and y and solve for our a value. So we have that y equals 20, and that x equals negative 3. So we have 20 equals a, and then negative 3 plus 2, and negative 3 plus 1. So now we have 20 equals a, and then this would be a negative 1, and this would be negative 2, and that would give us 20 equals a times a positive 2, divide by 2, divide by 2, and we get 10 equals a. So then our function, we're going to plug in 10 here, and then we're going to use this one here. So we're taking this here, and we're plugging a in. So our final answer is y equals our a, which was 10, and then x plus 2, x plus 1. And that is our final answer. Go ahead and try the next one. So here it is before I plug in this point right here to x and y. So 3 and negative 3, and then it becomes negative 3 and positive 3. But again, it's opposite of what we're seeing there. So now I'm going to plug in this point to get a. Okay, and I plugged the 1, 2 in, and I got that a equals negative 1/4. So then I put my a in the front, and I put my x-intercepts there, and that is your final answer. And that is it for section 3 of topic 2.